Hi, this is Gus Jansson with MATRIX Robotics, and this is another tips and tricks video. And in this video, I'm going to talk about angles and how to build structures with angles. So in the first video, I showed you how to use the joiners and how the joiners fit inside the L-beams, and you can build orthogonal type structures so that the L-beams are at right angles to each other. By no means is that the only way of building with matrix. So in this video, I'm going to show you some little cool things about how to get things at angles and still be consistent with a grid so that the whole structure fits. Since matrix is based on a grid where all the units are an even number of holes going, both vertically and horizontally and in the third dimension, we're basically doing integer math. So the angle that really becomes useful is the standard 3, 4, 5 triangle, what's known as one of the Pythagorean triples. A triangle where it's a right triangle where all sides are an integer number of units. So in this case, if you just look at this right here, by the way, this is an older prototype part of a matrix system. It's a gold anodized piece. I'm just using it so it stands out in front of the clear anodized. So here you'll see that the diagonal is 5 units long, and when you measure distances, you should always count from 0, just like a ruler. A ruler starts at 0, so 0, 1, 2, 3, 4, 5. So this diagonal is 5. On the bottom you have 0, 1, 2, 3, 4, and then going up 0, 1, 2, 3. In fact, this gold anodized piece that I put on there is actually 10 from the very beginning to the end. So if you were to count all the way from there to there, the distance is 10 units. And on the bottom here it's 8, and then vertically it's 6. So this is still a 3, 4, 5 triangle, but times 2. All 3 sides are times 2. This by itself is a great way of getting started with building at an angle in your matrix system. For example, here's a matrix joiner with 3 L-beams, and then I'm sort of reinforcing it. I'm supporting it with the same beam that is 10 units long. It's an 11-hole beam, but 11-hole beam, the length of an 11-hole beam from the first hole to the last hole is actually 10 units. So this is going to be 8 on the bottom and 6 vertically, and you have a nice right triangle. It's a way of making things very secure, very rigid. Great way of reinforcing. If you have a robot that, let's say, has a tower, for instance, and you want to keep it from falling down, reinforcing it like this is a great way to start. So how might you do this when you're actually building a robot? I'm going to show you adding 2 C channels at an angle. To do that, I'm going to put together, first of all, I'm going to use flat beams to sort of build a hinge, letting me join these 2 C channel parts together. So these flat plates have gone onto the outside. Now this is going to hinge that way. Now, how do I make this stay on module? What I'm going to do is use first zero, 1, 2, 3, 4, 5, 6, 7, 8 is here. There. So here are 2 C channels taking advantage of that 3, 4, 5 triangle. This diagonal is 10, on the bottom it's 8, and going vertical it's 6. So it's a 3, 4, 5 triangle times 2. This is actually can be done in, if you want a different angle, this is a pretty sharp angle. We can easily create a different angle by making the vertical part 8, and then the horizontal part on the bottom 6. So here it's 6 on the bottom, 8 going vertical, and still 10 on the diagonal. Still a 3, 4, 5 triangle, just switch the numbers around. So here is a C channel. Imagine this perhaps going forward or on top of your robot, And here you have an angled C channel going up. All on module. I want to show one more thing. Now, that little sample that I showed you with the straight beam, I'm going to do a variation on that. This time I'm going to use a gusset plate instead of the straight beam. And I'm doing this for a reason. So this is a 3x9 gusset plate that I've put on top of the 9x21 hole big flat plate. Again, I have the diagonal, so this is 5 units, 0, 1, 2, 3, 4, 5, and it's a 4 on the bottom and 3 vertically. Now the reason I'm showing you this piece is because I want to show you that there are actually confluence points between these two grids. If you think of this as defining one grid, and this 3x9 gusset plate is defining another grid, you can actually find all these confluence points that I'm marking with the white quick connectors. This might seem very academic doing it this way. This actually is very handy because it's very easy to build things in Matrix where you have these kinds of relationship between holes, and then you have this, it lets you put things at this angle, even just two holes together. For instance, I can take these two beams and I'm just going to establish that angle right away, like this. Just two beams, two pins, and I have this angle. This is in fact the exact same angle as what you would get in a 3, 4, 5 triangle. This is about 53 degrees. It's about the larger of the angles. I can actually make the sharper angle of the 3, 4, 5 triangle like this. In this case, I go up 3, down 1 on one side, and then over 3, up 1 on the other side. This is the same kind of triangle that you would see in the 3, 4, 5 triangle. Very useful. Here's a robot that uses this. This robot, the main front part of the assembly, where the motors and the controller and the wheels are, is pretty much horizontal with the ground. This rear assembly that goes to the caster wheel has that exact same relationship that I just showed, this kind of function, this kind of geometry to create this angle. In this case, I have a C-channel piece that goes vertically, and I have another piece that on the bottom to give it the kind of, imagine these things put together here, which is, since this is 3 across that way, I can do that same kind of geometry to get that same angle. And in a way, what I do is I cancel out that geometry on the actual part that holds the caster wheel, so that the caster wheel kingpin axis is vertical. This is a great way of building robots. You're not limited by just 90-degree angles that you might expect, and you can still be completely consistent. Since you have an integer number, when you use the 3, 4, 5 triangle, when you base it on that, you still have an integer number of holes, integer number in your grid. You can be completely consistent. You got to think a little bit while you're doing it, but it will come together. It'll be really nice. More information about Matrix Robotics at matrixrobotics.com.